Okay, welcome to the video on one sample mean confidence intervals, and this is 7.3. So let's just do a quick refresher on what this means. In a population, we may be interested in the mean of the population or the mean of populations, the standard deviation right here. So when we take a sample out of here, we're going to get an X bar. We take another sample, we can get another X bar. Okay, so if you recall that the average of all these X bars, the average of all these X bars, the average of all these X bars is equal to the same population if X bar is a biased estimator, which it will be. Okay, so that's mu. And then how much do all these vary from each other? What's the standard deviation of all these X bars? The standard deviation of all these X bars is the original standard deviation. It's the original standard deviation divided by the square root of n. Okay, so this is something that I'm going to add on, that if this is known, if the standard deviation of the population is known, we always use z's for our critical values. Okay, so everybody should be comfortable knowing their z's. Okay, so now we're trying to capture this mu for a confidence interval. So that's what this means. We're trying to capture this mu, sort of like we're trying to capture that p. But now we're trying to capture this mu. So there's the same way before. If I was at a 95%, that'd be 195, and this is 1 is not 1 minus 9.5, 1 negative 1.95. And if I took this, and if I randomly took an X bar from here, a sample, if I took a sample of a certain size, let's say that sample fell right here, we would catch that, we would catch mu. Mu would fall really close. We caught it, okay? So this would be your lower limit, and this is your upper limit of your confidence interval, because we're trying to, this is what we're trying to capture, okay? And we're only as confident as the confidence interval that we give, okay? 1.96, not 5. 1.96. Okay, so the formula for this, if you want to just play around with this one time, is this times the standard error. This is the standard error. What's the standard deviation of the statistic? Once we use S, it'll be the standard error. So that's the formula if we want to do this the long way. Okay, we call this a point estimate. Point estimate. Okay, so this estimates this mu right here, the population mean. Sorry about that. So anyways, if you want to play around this and do this by hand, take your time and do some by Statcrunch and just get a little better at this stuff instead of just doing Statcrunch alone, then play around with this and you'll kind of get an understanding of it. This right here that's your error. The error is the distance from here to here. That's going to be your error. The distance from here to here. And that distance is your z star times the standard deviation. Okay? See, that's your standard deviation. To get your standard deviation 195%, you just go 2 times that, or 1.96 times that. Okay, so when we're using Statcrunch, okay, for a one sample mean, we want to use our, we'll go do it. When we do it, you'll see how to do it. But what do we need to know? We're going to have to know our sample size and probably our sample mean. But I figured let's go ahead and just do some of these homeworks. Might be a good way to see how to do these. So it looks like, let me pull this up real quick. Okay, good, it looks like I have them here. So, and we will have to go backwards on this too. Let me write this formula down real quick. Let me put this on top. Keep that float. We'll just get to it. I'll get to the formula when we get to that one. But let's say number 1. Okay, a point estimated is valued. If we want to estimate the population parameter, Okay, so the population parameter, okay, is this guy right here. That's our population parameter. We're trying to estimate this. So what's the best thing to estimate this? One of these guys. Okay, but what do we call this? This is one of our sample means. That's our sample mean. So a point estimated single value estimate that, yes. The best point estimated population is the sample mid-range. No, we never talked about that. Sample mean, or the sample mode. Sample mean. That's our best one. Okay, so let's go to 2. So how many adults? Okay, so that's a backwards problem. We'll go back to that. Okay, so find the best point estimate for the mean value. So here's a question. Okay, we took 40 people and the x bar was 141.35 and the standard deviation. So did they give a sample or population? They gave us the population. Find the best point estimate for the mean weight. Okay, so the best point estimate that we have is just what we got from our sample. Nothing else. The point estimate is the average. See, this is the point estimate of this. Make sure I put it in right. Okay, so now let's find the confidence interval. So to find the confidence interval, if you use this formula, you will find it. So I'm going to show you how to find the z star. Okay, I'm going to show you how to find the z star. So the z star for 99% is some homework that is in 6.2. So that's 0. And if I'm at 99%, okay, what's to the right of that? That means this is 1% and this is 99%. So all we're doing is finding the z-score. So let's just do a quick review. You guys have done this before. I know because I just did a video on it not too long ago. Okay. So this is just a little quick reminder. So we went to calculators. We went to normal. This is the standard normal. I'm trying to find a z. So I want this left to be either 99 or the right to be 100. Oh man, where'd it go? Let's go there again. Here it is here. So I want this to be 0.99. 0.99 less than. See, 0.99 is less than or 1% greater than. Compute. So this is it. 2.326. 2.326. So if you're going to do this by hand, the z-star is 2.326. That's the z-star. That's your critical value for 99% or 1% to the right. That's if you want to do it by hand. This here would be 32.47. This sigma, the n would be however many people we took, which is 40, and the x bar would be 141.35. So you could add the margin of error, subtract the margin of error, and you get the same thing. But we're going to go ahead and use Statcrunch. Okay, so what we want to do is we want to go to our z-statistic. Z-statistic, one sample. They didn't give us data. If they gave us data, they give us all the x's. They gave us summary. So we need the sample mean, which is the x bar. That's our sample mean. Okay, we need the standard deviation from the population, which is 32.47. And we also need how many people we sampled. We sampled 40. Okay. It's important to know that if we know this, the sample size isn't important. We don't have to call on the central limit theorem. Okay, so we want to go next because we don't want to do a hypothesis test next yet. We want to do a confidence interval. Here's our sample right here. Lower limit, how many we need to round to 2? 131.29. And we want to go over to 151.41. And that's going to be it. Maybe not. What did I do wrong? Something's wrong here. Oh, Did y'all see? I already know what I did wrong. Darn it. You probably caught it before I even did. I didn't pay attention to what confidence interval we did. So one sample. I didn't pay attention to what confidence interval. It was probably on a 195. 141. See, this would be good so you guys don't make the same mistakes. Try to go too fast. See, I'm doing everything the same, and you'll notice that on the next page, okay, it's probably at 0.95. When I go to my confidence, see, 0.95. This needs to be a point. It's going to make my interval bigger. This number will be less, and this number will be bigger. 0.99. Here we go. Here we go. 128.13. See? 128.13 in my upper limit. If this is wrong, you'll never hear it because I'll re-record. But I know it's right. 5.7. Okay, there you go. So make sure you put in the right percent. Okay, so this would be the same thing. Here's your sample mean, here's your standard deviation, same thing. Okay, same thing. Here's your mean, here's your n, there's your standard deviation. Here's your n, here's your sample mean, here's your standard deviation, 0.99, same thing. Same thing. But let's look, because this is data. It looks like they're giving us data. Okay? Construct a 90% confidence interval. Mean gross population of all movies. Assume that the population is $100 million. Okay? So here this is. So let's see if this will open. So what you'd have to do is you'd have to open these in Statcrunch. So if you pull Statcrunch up, so you go stat, you'd have to put all these in a list. You have to put these, see, 117, 3. Okay, so just continue this on. 102, etc. Put this whole list in, and you're going to go stat, z statistic, one sample, but now it's with data. So it's with data, select that. Okay, standard deviation was what? 100 million. Remember, these are all millions. Next, I want a confidence interval, and what percent did we want? We wanted 90, so put this at 90. Calculate. Okay, when you calculate, I only have 3 in here. Okay, you need this whole list in. Okay, so that's how you do that one. Let's just leave that open. Try to get a backwards one. Okay, find the sample size. Okay, so the sample size formula is I'll just go ahead and run this formula real quick for you. I'll show you how I showed it in class, but this number here, okay, this is your error, and I want this number to be less than some e. See, I want this margin of error to be set less than some 4 points or 3 points. Okay, within 4 points. So this is going to be your e. So your e equals 4. What's the standard deviation of the population? Standard deviation of the population is 25. But confidence, z star is, I think it said 90%, so this is 1.645. Okay, 0.645. So if you look, all we have to do is find n. So you plug that in here, find this here, and you plug this here. But run in the algebra. Okay, I'm going to run the algebra first just to give you the formula. So I want to divide this z star, divide the z star. Now that cancels. So now what I'm going to do is I'm going to see, so now I'm looking at this. but I'm going to group this together, this whole thing together. And I'm going to, okay, so what I'm going to do is I'm going to divide by this. I'm going to divide by this. I'm going to divide by this. Okay, so then that cancels. So I have a 1 over here. You have a 1 over here now. So now I have this ugly mess. Okay, but I have to get rid of this guy right here. I have to get rid of this guy. So since he's in a numerator, I can multiply the square root of n here, multiply the square root of n over here. It's on the numerator, so these two cancel. Okay, so then now this is just going to be this over this. It's the square root of n. So now I just square this, and I square this whole side. So here's the formula right here. I'm just going to switch them around. So it's going to be n, because if I square a square root, the n disappears. N is greater than the standard deviation squared over the e z star squared. Okay, so their formula, if you get this thing wrong, all they're doing is they're flipping this thing. See this thing in the numerator, or the denominator down here on the bottom? If you have something in the denominator, I can flip this and put this on the numerator. So all they're doing is this. Z star, which you should be comfortable with, squared times the standard deviation squared all over e squared. So that's the formula they'll give you if you miss it. And they're just doing algebra. Okay, so let's use my formula. Let me pull up my calculator. Okay, so now let's look. E is 4, so 4, divided by z star, which is 1. I'm using this formula right down here, 1.645. Enter. Now I have this inside part. Now I want to square it. Okay, so squared. Okay, so now I have this standard deviation here, which is 25 squared. So, which I believe is 6225. 625 squared, or 25 squared divided by this number down here. Second answer. 105.7, so let's try 106. Alright, see? That's it. Okay? You can do the same thing here. Loss within 0.06 pounds. Assume the puppet standard deviation is, so this is your error. Okay? That's your error. This is your standard deviation. So watch this. This is at 11.2 squared. That's my standard deviation. Divided by, okay, what's the error? How much do I, within 0.67, so 0.67 divided by, what percentage is it? 90%, which is 1.645. This is in your charts, guys. If you're not sure about this 1.645, I just did one earlier. You could do the same thing. You could find this using, you just do your z's. Okay, for if 90% is in the middle, you would do a z for 95%. And I want to square this. Square that. So all I did was put this number in my formula. 757. 757. Okay? So that's how you do that. Okay, so everything should be fine there. Number 2 is to find a backwards problem too. You could just use this formula. Alright, thanks. Good luck.